Okay, we're in section 25 of the notes. And this says, let's continue. I guess let's continue with what we've been doing, which is essentially pre-calculus and then using the first and second derivative to refine the picture. Right? They give me a function, they give me a picture, and then they're going to ask a series of questions about this picture, ones that we should be well aware of at this point. Now, granted, I will point this out. Sometimes it's very difficult to get a derivative. I know that, and we'll talk through that. All right. Then we'll do the examples. So let's start off with this, basic thing, a repetitious loop, by the way. Pre-calculus, that is, the analysis we learn in pre-calculus. And then we go to calculus, first and second derivative to refine the picture, min maxes, concavity, yada, yada, yada. So I'm going to switch screens. And I'm going to go to my whiteboard. And let's take a look. And what am I seeing over here? I'm seeing I got a function, I got a picture of it. And I just want to go through the pre-calculus of it. All right. So the pre-calculus would be, well, I'm kind of glad they gave me a picture because it helps me a great deal. But looking at the function, I'm just going to do the 119 material, the math 119 material first. All right. So I got f of x equals, let's see, it's a root function, right? So 2x squared plus 1. What's nice about that root, the radicand is always positive. So I'm not worried about, negative numbers. But the bottom I'm worried about, and the domain of this problem is going to be all the real numbers except for the bottom becomes 0. So I'm going to say all the real numbers, but the bottom can't be what number? It can't be 0. So what would make it 0? 5/3. So I'm pretty comfortable that this is an asymptote over here, and it's a vertical asymptote. We'll go through the work though, and the vertical asymptote is x equals 5/3. All right. I want to write the limit down, and yes, I know it's difficult, but I want to emphasize I think you can do it. So limit as x approaches 5/3 from the right of f of x. And, looking at that, I realized the bottom is the only real problem I have. The top's always positive. No matter what I do, it's a positive number. So then the question comes is, if you're doing sign analysis, it does change sign at 5/3, by the way. And to the right of 5/3, it would be a positive number. But it's getting close to 0. So it's going to blow up to plus infinity. That makes sense. And I'll put that behavior in right over here. Limit x approaches 5/3 from the left of it. Now, what do I know about that? The top's always positive. I don't have to worry about that at all. It's the bottom I'm worried about. It's going towards 0, right? But through what kind of numbers? Negative numbers. Basic sign analysis. So minus infinity. So I got that behavior over here. All right, got it. All right, what am I going to do now in math 119? I'd probably look for horizontal asymptotes. How do I do that? Limit as x goes to infinity. And we get this, 2x squared plus 1, 3x minus 5. Now, I'll be honest with you, in math 119, this might have been a little bit too much to ask a student to do. But since you guys are in math 121, I think it's going to be relatively simple to do. So I'm going to say in math 119, I don't think I'd ask a student to do this, but at 121, I would. And I want to point out, if x is greater than 0, x would be identical to the square root of x squared. So let me do this one over here, and I'm going to be using this. I'm going to divide the top by the square root of x squared and the bottom by x. So limit as x goes to infinity. We did this in the beginning of the semester, by the way, in math 121. What do you get on top? The root of 2 plus 1 over x squared. What do you get on bottom? Divided by x, you get 3 minus 5 over x. Well, if you go towards, infinity, what would you get? Well, you get the root of 2 on top, certainly, and you get 3 on the bottom. So now I'm going to say, I know this asymptote now. This is this one over here. This graph goes towards that asymptote. What's that asymptote? Y equals, and again, we just did it, root 2 over 3. All right, let's do the other one. And I got to do this now. If x is less than 0, the square root of x squared is actually going to be minus x. So let's do that one. And we're doing this one now. So it's going to be limit x goes to minus infinity. I'm dividing the top by this, which would give me 2 plus 1 over x squared. That's pretty simple. And I'm dividing the bottom by this, which is giving me minus 3 plus 5 over x. And what do you get over there? Fairly simple. You get the root of 2 over minus 3, which is minus root 2 over 3. That's when we go towards minus infinity. That's this asymptote over here. And we're going in minus infinity in that direction. So y equals minus root 2 over 3. All right. Now, what else would you have done in math 119? You might have looked for like x-intercepts. And I'm looking at it, and there are no x-intercepts. And why is that? The top would never be equal to 0. No x-intercept, there's none. So I know that there's an x-axis somewhere along here, but it's never touching it. Now, where would the x-axis have to be? Some over here somewhere, right? That's where the x-axis is, all right? Where's the y-axis? Over here somewhere. Do I need to draw that in? Not really. So I'm going to erase that. All right, what I want to do now is I want to see, are there any y-intercepts? Well, what's the y-intercept going to be? Set the x to be 0. What do you get? Y would equal, we're setting x to 0, root 1, right? Root 1 over what? Minus 5. So that's going to be minus 1/5. All right. So what do I got over here? If the x is 0, I would get minus 1/5. All right. So we just say, I don't have much information here, other than the fact I got behavior. And I'm not going to say you're going to get this right pre-calculus, but I know there's a connection between the two. Like, for example, if I were to look at this and this, I know there's a connection. Look at this and this, I know there's a connection. I might not get their detail, but I know the connection. Does this help me? Not a great deal. It doesn't help me a great deal. All it says is when it's crossing the y-axis over here, it's going to be minus 1/5. Right? It's going to be somewhere over here. But it's not helping me with the graph. All right. Let's do the other things about this graph. Maybe symmetry. And looking at it, I don't see any symmetry, but you could test for symmetry if you want. Like you could do odd symmetry, even symmetry. There's no way looking at it, it looks even or odd to me. All right. But I'm going to say, if you do the test, you're going to find that out. Or the test, does f of x equal f of minus x? That would mean it's even. Does f of x equal the opposite of f minus x? Then you would say it's odd. Okay, I think I'm ready to answer some questions now. Are there any x-intercepts? We claim there's none. Let's read what they said. It says 2x squared plus 1 is never 0. Wow, no x-intercepts, just like we said. Let's go to the next question. Are there any y-intercepts? Well, we just did it. We said 0 minus 1/5. We got that right. Did we do the vertical asymptote? We sure did. What did we say the vertical asymptote was? 5/3. We did that. How do we do it? We did it by limit. We did it. We got 5/3. Now, did we put those limits down? Let's go back over here. And they were done over here. What did I say about these things? That would be unreasonable for, I'm sorry, they're over here. That would be unreasonable, not unreasonable, I'm sorry, that wouldn't be unreasonable. That'd be reasonable for a math 119 student. Of course, you're in 121 though, certainly reasonable. All right. We got those two, we did it. It's all typed up for you. Horizontal asymptote, did we do that? Yeah, there's 2 of them. What do we find? Let me point out what we found. We found these 2 over here. Root 2 over 3 minus root 2 over 3. We did both of those limits, by the way. These are going to be we wrote those down as well, right? What we didn't do, we did not do the derivative. So what I want to do is I want to grab the function. I know this is difficult. Again, I can't say it times. We're trying to encourage you to try. That's all we're doing. We're trying to encourage you to try. So I'm going to do this derivative thing now. And it's going to be tough. I'm not saying it's going to be easy for you. So what I got to do is I got to look at that guy and take its derivative. I got to write it down now. You know, I'm going to need more room than that, aren't I? This one I'm claim to students. A lot of times with students, I try to jam it into a really small space. I don't think it's a good idea. I'm going to give myself some room over here. And don't worry, we're going to match their answer. Square the bottom. Bring the bottom to the top. Times the derivative of the top. Well, that's not easy, but I can write it down for you. It's going to be 2. And then when you get there, 4x. We'll take care of that later. Minus the top times the derivative of the bottom, which is 3. All right, so I'm done. You're not done. This is of no use to me. What I'm going to do is I'm going to multiply top and bottom by the square root of 2x squared plus 1 and the number 2. Let me put that down for you. The bottom is going to be multiplied by 2 and by the root of 2x squared plus 1. We'll simplify later. So what do you get? You would get 3x minus 5 times 4x. Because if I multiply this first term by what I said I was multiplying by, that bottom would disappear. Then what do I get? Minus, or multiplying by 2, right? So I get 6. Well, if you multiply the root of 2x squared plus 1 times the root of 2x plus 1, you get 2x squared plus 1. Wow, that looks pretty easy. Let's keep going. I'm going to factor out a 2 on top. And what do you get? 6x squared. We're doing this first, by the way. Minus 10x minus 6x squared minus 3. Wow, this is really tough, doesn't it? 2, 3x minus 5 squared root 2x squared plus 1. Well, I'm going to say I got some cancellations here, right? Like they just count. 2 divided by 2 is 1. This is nice. Glad that disappeared. I'm going to factor a minus sign out from the top. What do I get? Minus, let's see, you get 10x plus 3. We'll check the key later. And on bottom, you get 3x minus 5 squared. Oops, sorry about that. The square root, 2x squared plus 1. Well, let's say if I did a good job. I'm going to look at it. I'm looking at their answer. I'm looking at my answer. And I'm wondering, did I get the same answer? It's a miracle. We got the same answer. All right. Now someone says, what do you do with that? You might be exhausted. Might need to take a break. I'm not taking a break though. I'm going to move forward. Now someone goes, how are you going to move forward in this? I want to analyze it. Now, before I do anything, I want to point out on this number line, we're analyzing the first derivative. We need to know the critical numbers. The critical numbers are in the domain of the problem. And there's a number that's not in the domain of this problem, and that's 5/3. That needs to be removed immediately from that line. Is there a critical number? Like, is there a place where this derivative would be undefined or equal to 0? Well, there's a place where it would equal 0. And would that place be? Well, looking at it, it would be when 10x equals minus 3 or x equals minus 3/10. Where would that number be? Over here somewhere. All right. What am I going to do now? Sign analysis of that derivative. And then we'll go back to the picture and we'll talk about it. What's a good number after 5/3? I'm going to say maybe like 10. If you plug 10 in, what would you get? The bottom is always positive. So you get a negative on top, decreasing. If you took a number between -3/10 and 5/3, like 0, you'd still get a negative number on top, decreasing. If you took a number below -3/10, like -1, you would get, let's see, a positive on top, and the bottom is always positive. So what am I seeing now? I'm seeing a maximum here. Where does the maximum occur? At -3/10 f of -3/10. Let me go back to my picture and see if this makes any sense at all. So what do I say? I do see a maximum over here somewhere. Where's that maximum? -3/10 f of -3/10. Now, if you remember what I said, what I say, it's increasing, decreasing, decreasing. Makes pure sense. All right. Now, again, I made a mistake at the numbers, but it makes pure sense to me. Let's take a look, see how we're doing. And what are they telling you over here? You'll need time to verify this. We took the time, we did. It's tough, but the algebra skills will improve by doing these verifications. Yep, you're going to start learning more and more about algebra. However, you should also consider using technology to do these derivatives because sometimes they're difficult, but you got to do the handwork. The only candidate for extreme is -3/10. We did put that down. And what was that? That's a local. What was it? A local. This is a local max. All right. So we did that. What do we found? We found that the only candidate was -3/10. The derivative interval is always infinity to -3/10. Is always positive. I did put that. Let's go next page. It says and the derivative is -3/10 5/3, always negative. That's true. Certainly the graph, although not tagged down to an axis, does indicate that. And we did write that down. The one thing I did not do was I didn't evaluate it. You don't need to. All right. Where's it increasing? I want to point out, if someone says, where's it increasing? Go back over here. Where is it increasing? It's increasing on this interval. And what's that interval? -infinity up to -3/10. All right. So let's go to the next page. I got this one over here. Where's it decreasing? Well, let me go back over here. It's decreasing here. By the way, this is increasing. It's decreasing where? -3/10 up to 5/3, union 5/3 to infinity. Let's take a look, see what they put down. Yep, seeing that right there. We're doing it right. All right, second derivative. This is going to be trouble. We'll talk about it though. All right, so what I'm going to do over here, I want to take this thing I just found, which to me is sort of a nightmare. And I'm going to paste it in. And I'm going to push this on the side for time being. I will take a short reprieve from this, by the way, but what I want to claim over here is that this is going to be tough. There's a point to it, though. The point is this. You are going to have to do some heavy lifting, but it's exhausting. For a lot of students, it's overwhelmingly exhausting. You might have to use a tool. We'll talk about tools later. All right, let me write this down. Square the bottom. That was easy. Oh, by the way, this is negative. Sorry about that. Take the bottom to the top and leave him alone or her alone. It's work, though. I know that. Times the derivative of the top. 10 minus the top times the derivative of the bottom. This is where it gets tough. Yep, it's going to get tough. Let's keep going. Oh boy. Let's see. Boy, that's a lot of work, huh? Oh boy. Someone says I got to take a holiday on this one. Not me. All right, I'm gonna do a little work over here. I hate to do it in front of you. There's nothing worse than watching someone work, by the way. So I want to encourage you, if someone's working, you should also work. All right, remember, these things are being recorded. You can watch it at a later time. That reduces the 2, right? Well, what I'm going to do is I'm going to multiply the top and the bottom by this business over here. No one enjoys doing this, by the way, but I gotta write it down. Let's take a look at this. It's negative 3x minus 4. Whoops, made a mistake already, didn't I? 3x minus 5 to the 4th power, 2x squared plus 1 times the root of 2x squared plus 1. I got to do this now. 3x minus 5 squared. I'll multiply it by a root. That's pretty simple. 2x squared plus 1. I'm going to see the 10. Wow. Minus 10x plus 3. That's not that bad. Times, let's see, that would be 2x, 3x minus 5 squared. It'll be a miracle if I get this right. Plus 2. Well, you know what? I see 2 times 3. I'm gonna erase that. I'm gonna say plus 6, 3x minus 5, 2x squared plus 1. Wow. Let's keep going. All right. Let's keep writing it over and over. We have a goal, though, to match an answer key. There's a point to this, though. And someone says, I don't know what the point is. The point is you need to start to work, including you're doing something you can't do. You start to realize you can't do something when you do it. I got to do a lot of work here, though. I'm going to write it down now. I know it's negative. It's work, though. It is. 2x, 10x plus 3, 3x minus 5 squared, plus 6, 10x plus 3, 3x minus 5, 2x squared plus 1. All right, it's work, and it's I don't like this work. One of the things about going to school, you're going to start to learn, is you're going to be doing things you don't enjoy doing, and that's really critical. You might say, I want to major in this, and then you're majoring, you don't like it. You want to get out of it before it's too late. Now, by the way, I'm not saying about this. I'm just saying about your majors, not about what I'm doing now. about your majors. If you like, for example, let's say you're computer science, but you can't stand coding, it's probably a good indication you don't like computer science. All right. If you're in mathematics and you don't like doing things like this, probably you're not really interested in mathematics. All right. So I'm looking at this thing. I want to point out I'm seeing things. And again, there's a point to this. I'm seeing 3x minus 5 in every single term. So what I want to do is I want to reduce the problem to reduce the amount of work I have to do. Let's write this down. It's still going to be a lot of work, by the way. I'm going to divide top and bottom by 3x minus 5. And let's write down what you get. 3x minus 5 cubed, 2x squared plus 1, square root 2x squared plus 1. What do you get now? 10, 3x minus 5, 2x squared plus 1, minus 2x, 10x plus 3, 3x minus 5. Oh boy, it's still going to be work, isn't it? Let's take a look. Then we get what? Oh boy, I guess get 6. 10x plus 3. And 2x squared plus 1, right? There's a point to this. I know I keep telling you that. The point is this is really getting long. We'll talk about it later. Whoa, let's take a look at that. I got to make my life easier. I'm going to look at these two terms here. And I'm going to factor out a common factor just from those two terms. Now, someone says all the terms have something in common. Well, they do have a 2 in common. But other than that, they really don't have anything else in common. So I'm going to factor out from the first two terms a 2. Whoops, maybe I went too far with that square bracket there. And I'm going to factor out 3x minus 5. Okay, what do you get? 5 times 2x squared plus 1. Minus x times 10x plus 3. Let's keep going. Plus 6, 10x plus 3, 2x squared plus 1. All right, let me stop the advertisement. There's a point to this. We'll get there. All right, let's keep going. Minus 2, 3x minus 5. I'm going to do what's inside that parentheses now. I'm going to write this down for you. This is 10x squared plus 5 minus 10x squared minus 3x. Well, these disappear. And what do you get? 5 minus 3x. Don't panic yet. Well, let's take a look over here. Plus 6. I'm going to multiply this out now. And what are you going to get there? 20x cubed. Don't panic yet. Plus 10x. Plus 6x squared. Plus 3. Let's write that down. 20x cubed. Plus 6x squared. Plus 10x. Plus 3. We'll get to the point later. Don't worry. What do you get on bottom? 3x minus 5 cubed, 2x squared plus 1, square root 2x squared plus 1. All right, let's keep going. I'm going to rewrite this guy here as 2 times 3x minus 5, 3x minus 5. Let's write that down. What are you going to get? 2 times 3x minus 5 squared, which is 9x squared minus 15x minus 15x, which is minus 30x plus 25. Plus, well, let's just multiply it out now. What are you going to get? 120x cubed plus 36x squared plus 60x plus 18. Well, most people's pens would run out of ink at this point, right? You should not be adverse to writing, though. Oh boy, I don't know if I can keep going on. 120. You know what? I forgot the minus sign. It's way up here. Minus, minus, minus. Sorry about that. I forgot all about that. So what do you get over here? 120x cubed. Let's see. 18x squared and 36. Well, let's see. That would be 18 and 36, 54. $18 and 36, 54x squared. Minus 60x plus 60x. Gee, that disappeared. That was good. 50 plus 18, 68. 3x minus 5 cubed, 2x squared plus 1, square root 2x squared plus 1. Oh, I guess I got to do something else now, right? Boy, I hope I didn't make a mistake. There's a point to it. I'm going to say minus 2, because I'm factoring a 2 out, 60x cubed plus 27x squared plus 34. And I think we're done. Someone says, that was so much work. Look at all that work. Let's see if we got the right answer, though. I'm going to copy. Where was that? I got to even find, it's so long, so far away. Look how that thing is dwarfed by how much work I put down. And I really apologize for all this pushing things around here. I don't think I'll ever get there. Look how small that guy is. I don't think I can grab it anymore. Just going to paste it in again. I copied the wrong guy. Let me undo that. See if I get this, blow this guy up a little bit. That's the guy I want, isn't it? Let's see if we got it. I'm going to go through it one step at a time. And I think I made a mistake somewhere, but I got really close. 60x cubed, 27x squared, plus 34, 3x minus 5 cubed, and this over here is 2x squared plus 1 to 3 halves. I notice I'm missing a sign there, though. You see that? All right. Here's the point. My claim over here is that doing that is very unproductive, what we just did. So what I want to do is I want to go back to my computer and talk about what we'd like you to do. All right. So I'm going to go over that with you. And just give me a second, give me a new share. And just give me a second here. I'm going to open my terminal. I'm thinking for the most part, most probably do is really kind of simple, take derivatives and stuff. But you notice I almost got there, but there's a sign difference there. All right. So I'm wondering, is what I did right or wrong? I don't know. Who knows? Maybe the answer key is wrong. Maybe I'm wrong. Maybe I'm going to lose sleep over it tonight. Not really. Let me clear. Let me reset. Let me get a variable X. Been doing this for some time. Again, a lot of students say, I'm not going to do that because I'm not getting graded on my Sage work. It's kind of foolish. You want to start doing this. You want to start practicing using a computer algebra system. Does it have to be Sage? No, but you should know how to use a computer algebra system. Then I'm going to say f of x is equal to the square root sqrt 2 star x squared plus 1 divide by 3x. Whoops, I can't do that. All right, you got that. Certainly, what do I want to do now? I want to start playing around with this now. And, maybe I could do some of these problems over here. Now, let me do this one over here for you. So limit f of x equals 5 divided by 3, direction equals right. I don't know, maybe you can't do it. Infinity, that was good. Let's do left. I realize what some students say, if a computer can just, why do I need to learn? You are never going to get near a computer or a real world problem unless you can do things by hand. Let's do this one over here. Limit f of x equals infinity. It might seem weird to you, but Sage uses the 2 zeros as a short way to write an infinity down. 1/3, just what they got. Let's do minus infinity. Yeah, just what they got too. Miracle, right? Let's keep going. Let's see the derivative. All right, let's see if we can do that. And I'm going to say df of x is equal to the derivative, diff, f of x with respect to x. And I'm going to do full simplify. You know what? Let's not do full simplify. Let's see what happens. Let's display df. You know how quick it did it? Oh, I don't know if that's right. So let me see if I can do full simplify in that. Or I'm going to do factor. I have no idea what's going to happen. Wow. Same answer. Minus 10x, the opposite of 10x plus 3 over the square root of 2x squared plus 1. Same answer. That's incredible. I want to do another function, df x is equal to the derivative of df of x with respect to x. Let's see if that does it. I want to see if I get that one over there. Well, let me display it. That doesn't look right. So what I'm going to do over here is same thing, factor. By the way, I know that's difficult for students to realize. So they're looking at something, they have no idea what they're looking at. And that does happen. Let's take a look. 2, 60x cubed, 27x squared plus 34. My God, that is correct. 2x squared plus 1 to the 3s, 3x minus 5 cubed. Yep, I made some sign error. Now, do you think I'm going to go back to my notes? Let me go back to the new share then, okay? Okay. After all that work, let me point out, I made an error somewhere. I made one small tiny error over here. You could go back and search all over your work now, which is all over the place, looking kind of dirty and stuff, and wonder where that error popped into it. All right. I'm starting to see where the error popped in right now. I forgot I did this over here. You see that? And then I went back and said, oh, I forgot the minus sign. I didn't forget it. I thought I forgot it. I got to erase that now. Oops, I got to get eraser out. So you know what? I get to look back over my work. I'm in agreement with it. Here's the problem though. A lot of students will look at work and they won't be able to look back over it. All right. It's important though. You start to realize some derivatives take so long to do, they're just not worth doing. Let's go to the real question though. Not only was I asked to get the derivative, but I was asked to do something with the derivative. So I got the second derivative. What are you supposed to do? It's all about concavity. So let's talk about it. I'm analyzing. I want to point out what we're analyzing over here. And there's another point to this conversation. We're analyzing this for concavity. Now, by the way, there's a number we need to remove along the number line. And that number we need to remove along the number line is 5/3. It's not the domain of the problem. My problem is this, though. I need to find out when this thing is undefined. It is not undefined anywhere because 5/3 has been removed. The other thing is, when is it equal to 0? So I'm faced with this, a very difficult problem to do. I'm faced to find out, when does 60 x cubed plus 27 x squared plus 34 equals 0? Now, by the way, you did problems like this in Math 119. Use the rational root theorem. What I want to do though is this. I want to go back to my computer algebra system. And what I'd like to do is I'd like to verify that I can actually do this in a computer algebra system. And that's why we want you to learn a computer algebra system. I'm going to do another share with you. I'll keep my whiteboard active, by the way. What I mean active for me. Hopefully you have a notebook and you're keeping things active too. So what am I going to do? I want to solve an equation now. All right. I want to make sure I'm sharing the screen with you though. Give me 1 second. Yeah. Okay. Clear. Maybe I shouldn't clear so quickly. I'm going to copy this first. What do I do? We want to solve the top for 0. Let's see if Sage can do it. Here's what Sage does. And by the way, this is going to be remarkable. I hope you realize how quick it did it. It just looked at that, boom, the answer's down. That quick. It does it that quickly. Here's my problem. I was going to look at that. I have no idea what's been given to him. So I'm going to say over there, what's been given to you is a bunch of answers. All right. How many answers would you expect? 3 answers. These are really complicated answers. All right. So I'm going to start talking about one answer at a time. And what I'm going to do over there, I'm going to just copy one of the answers here. Ooh, they're really tough to copy, right? So what I'm going to do, I'm going to do the problem again, and I'm going to put a decimal over here, okay? No, it still does it. So let's see what I'm going to do over here. I'm going to find root. No, it's too much because I get an interval for that. Oh, it gives me exact answers, doesn't it? All right, let's take a look at them. So this one over here, I'm looking at, oh, I don't want that one. It's complex. You see that? You see the I? I don't want that. Let's keep scanning around. Here's another one over here. I'm reading it. Up, I see the I again. I don't want that. Let's keep reading it. Up, I see another I. I don't want that either. They're all over the place. Maybe this last one has no I in it. Copy that. So I did copy. You sure aware of that, right? Let me put 0.0 there. I'm going to see if it can do it. You know what I'm going to do? I'll do this. No, sorry. No, it's still giving me the I. Why am I not getting the real number here? Let's take a look at it. I'm not going to sift through it. I'm going to Wolf alpha. Let's do that over here. And again, we're still trying to solve this thing over here. I'm going to Wolfram alpha. I'm going to ask it to solve that equation for 0 and see what it does. Well, another nightmare. Gives me all those things over there. Well, it's all over the place. Product groups, sum of roots. Boy, it looks like everything is complex. All right, everything's complex. Let's go back over here. GSH said everything's complex. Wolfram said everything's complex. Let's read this. You need to find verifying this derivative, and it's much more difficult than getting the first derivative. There's no doubt about it. Again, you should also consider using technology to use derivatives. We've done that. We've got through that. We did the handwork too. What's the problem with the handwork? It was really difficult to get through. The only candidate for extreme is this thing over here. I should say the only candidate for, not for extrema, I should correct that. That should be for the change in concavity. Not easy to do, and it's yes, you use your calculator to solve this. You should be able to verify that only one real solution. You know what? I got to go back and wonder why I'm not getting the real solution to that problem. And I'm going to make sure I type that in correctly. So I'm expecting to get a real solution. And 60x cubed, 27x squared plus 34 equals 0. And I solved it. And why am I not getting what I'm expecting to get, which is, let me just write down approximate then. I have a tough time forcing it, aren't I? Let me make sure it's giving me all these I's over here. I got to be real careful about this, by the way. I'm sorry, there is a real solution. It's right over here. All right. I'm having a tough time getting that to give me an approximate. Let me click this. And I'm seeing it now. So they give me the approximates over here. And I want to go back over here. Again, it's a struggle. And what am I getting? Minus 1.0079. All right. So we did get it. We evaluate that. Let's go back to the graph. And we'll talk about it again. What am I finding? A point of inflection, concave up, concave down, concave up. You get the idea. There's only one point of inflection. Where does it occur? At this value right over here. All right. So here's the deal. Let me go back to the notes. Beginning was easy. There's no doubt about it. Like the pre-calculus, things were moving along pretty smoothly. Where do I try to get my stags? Typically, I don't think the first derivative was that bad, but for a lot of students, it's really bad. All right. You need to practice that. I think everyone in the classroom should get the first derivative. What happened to the second derivative? It was a killer. Not only was a killer, I am then faced with an equation that to me was incredibly difficult to solve. So what I do, I still went to technology. So it wasn't until I got to question 8 that I went to technology. In question 8, what did I do? I looked at a computer algebra system to get the derivative. I was able to do that. I looked at the computer algebra system and find a 0 of 60x cubed plus 27x squared plus 34. It gave me 3 answers. 2 were complex, 1 was real. You know what? I should go back to my Sage to make sure. And again, I'm dizzy even looking at it. There is a real solution there, and I got to be really careful looking at this. And let me just take a look. I know there's a real solution over here. I got to look at it carefully. And let me just make sure I'm looking at that. Let me just display that again. Let's see where the real solution is. And I got to be real careful here. X equals, And I'm dizzy looking at this already. No, for some reason, I can't copy what I want to copy there and get it to work. I don't know why that's not working on Sage, though. I gotta look at it more carefully. Here's the deal, though. I did go to Alpha. Alpha did do it. What do we find out? The same answer I'm listing in the notes. I'm not sure what software I was using in the notes, by the way. It's not so bad. We can probably do that with Sage. I just don't want to spend any more time on it. Okay, let me point this out. We start doing examples. They really start simple. Simple's number one simple. Number two is simple. You need, if you know trigonometry is simple. Number three will be simple, really simple, by the way. They give you a nice little picture over here. Number four is going to be simple. I guarantee it. Number five will be simple. I guarantee it, with the exception of maybe the derivatives. I do want to point out, if you're getting stuck with the derivatives, try before you go to technology. But it can't hurt to go to technology to do that. Second derivative, a little more difficult. Eighth degree polynomial, a little bit more difficult. So as you go through these things, yeah, they get a little more difficult. You may want to consider starting to think about using technology for it. But I want to point out, there's only, that question number 8 was the only time I really did how to use technology over here. For the most part over here, I do point this out to you over here. We would love for you to read what we're writing down for you to look at. And it's about tool use. And there's a really great movie. It's Kubrick's 2001. And I really think the central theme of the 2001 movie, it's sort of like a religious theme, but the religious theme was that, what gives certain groups advantages are tools, all right? For example, if you look back over human evolution, certainly what gave one group advantage over another group was the use of tools. And in 2001, it's kind of like a funny beginning to the movie. The first tool they were using was the rock as a weapon, all right? And it was horribly frightening to watch people use tools, I imagine, for early mankind, or at least our evolutionary ancestors when they first picked up the rock. It's going to be tough when you pick up the computer, really tough. But you're going to have to do that at some point, because you can't do it otherwise. There's just no way for a successful, productive life without the use of a tool. Thank you.